So this is my lab number 2, Physics 2212. The little table of contents. So introduction, experimental model, data, glowscript model, and discussion questions. This is the introduction of the lab. So the purpose, which this lab will further go into lab one's experimental results and data. We'll create a more specific model for calculating the electric force and the electric charge. Some of the results, or this little preview, is that the new magnitude was 2.92503 10 to the negative 8 coulombs. This magnitude is much higher than the initial point charge model of Lab 1. The experimental model is mostly the same, and the glowscript model changes to a company of line of charges instead of a point charge to find electric force in the Q. Some assumptions are that air resistance is negligible and both U tapes have the same charge like before. The charge is also distributed evenly throughout the tape. So this is the more in-depth experimental model. So 2 U tapes in the surroundings. 2 U tapes are ripped off another tape to gather charge and brought close together to float on each other. Each positively charged is shown with attraction with hands, books, and repelling a negatively charged pen. Surrounding the systems do not affect the results in a large way. Fundamentals of this lab are Newton's second law, F equals ma, and Newton's third law, equal and opposite force, so Fe equals Fg. Gravitational force, Fg equals mg. Coulomb's law, which is kqr hat over r magnitude squared. And gravitational acceleration. The Newton line charge model can also be expressed through treated as a rod through the length of the tape, so E-rod formula. So this lab uses most of the same data as the previous lab, so the distance is the same, the tape mass is the same, the tape length. The formula of Q from E field for a rod is here as well. So Q equals mg times r parentheses r squared plus L over 2. Add those together, square root, and then times r, and over k, square root the whole thing times gravity, and that equals your new Q, which is the estimated value is 1.16 times 10 to the negative 7 coulombs. Most of the calculations were done through glowscript with these following formulas. Electric force is also from one small charge in a group of many on this model, making it smaller than Fg initially. Using the original Q value from lab 1, so not the estimated is much bigger and it wouldn't work. You wouldn't be able to see a vector here. So this value is used instead, 1.39245 times negative 8 coulombs. And this makes the tapes are also depicted as many charges, line charges, so many electric fields with the green vectors coming out. And the vector for Fe is smaller than the vector for Fg, so yellow is bigger than white. This is my second glowscript model and more revised to be accurate. So in this, the Q is different. The Q is scaled up. They're basically guessing the scale factor. And this is to make the electric force, the white vector here, match with the yellow vector with its gravitational force. And these values down here, the magnitudes also match. In the new model, the previous Q is scaled up by 2.100638 to make the vectors match and be equal like the point charge model. The new Q is 2.92503 times 10 to the negative 8 coulombs. With my code for the models, so my original Q and how I scaled it up, instead of using the estimated, which is much bigger, and the distance, length, mass, and this makes the charges along the tape. This makes color of the charges so you can see the tapes. And this is the vectors, the electric field vectors that come off each of these charges on this tape. And this is the electric force and the gravitational force down here. So the yellow vector is g-force, and the white vector is electric force. So these are the discussion questions. First question being, what if it was modeled like lab 1 as point charges instead of line charges? So the Q from lab 1 is 1.39245 10 to the 8 coulombs, which does not work for this new line charge model because this line charge model goes along the whole length of the tape instead of a point charge. So the estimated value, or in this case experimental, is much larger in the line charge than in the point charge. And these estimates differ because of accuracy. The point charge model is much less accurate than the line charge because it only accounts for a little chunk of the whole tape and does not get the whole influence from the electric fields of all of the tape compared to the line charge model, which has points along the entirety of the tape. So that's why it's more accurate. And that concludes my lab. Thank you.